start with this one. The extreme, this is extreme. The extreme value theorem, because it's extreme. The extreme value theorem says if f is continuous, let's make that spelled correctly. Continuous on A to B, it has guaranteed an absolute max and min on A to B. Guaranteed. So if it is continuous from A to B, there will be an absolute max and an absolute min. It may occur at the endpoints. It may occur at interior points. But it is guaranteed that there is a max and that there is a min. Okay? Only if f is continuous on the interval from A to B. Emily, good with that? Those of you in the Zoom that are paying attention, good with that?
Yeah.
Wonderful. That's pretty easy. Okay. Next one is the intermediate value theorem. Intermediate value theorem says if f is continuous on A to B, then every y value between f of A and f of B can be obtained from an x value on A to B. And so effectively, if I'm going from A, right there we go. If I'm going from A to B, doesn't matter how I get there. Every value between f of A and f of B can be found by choosing something between A and B. We might be able to get some values outside of f of A and f of B if maybe my functions are disappearing. No, I drew a function in there, didn't I? Didn't I draw a function there? It just disappeared. It literally disappeared. What in the world? It's not like I didn't even like erase it. There we go. Even if I go below on that interval, still every value between f of A and f of B can be found by choosing a value between A and B. That's what the intermediate value theorem says. Does that make sense to everybody? Yes, no, maybe. Great. Next theorem. Mean value theorem. Mean value theorem says that if f is continuous on A to B and differentiable on the open interval from A to B, then for some C on A to B, f prime at C is equal to f of B minus f of A over B minus A. Or effectively, that somewhere on that interval, the instantaneous rate of change is equal to the average rate of change. Or in other words, we could say the slope of f is equal to the average slope of f. The instantaneous slope, or the slope at a point, is equal to the average slope. And this one shows up fairly often. There is a little addition to this one that is sometimes called, well, it's always called, Rolle's theorem. Rolle's theorem is the MVT with f of a equal to f of b. So if f of a is equal to f of b, that tells us that the slope is 0. And so f prime of c equals 0 on a to b somewhere, which tells us that there must be a critical value of f on a to b. Everybody good with that one? Zoom people good with that? I know. Oh well. Let's see. Next one would be the mean value theorem, or sometimes called the average value theorem for integrals. That tells you that the average value of a continuous function is 1 over b minus a times the integral from a to b of that function. That one's pretty easy. Let's see, other theorems: extreme value, intermediate value, mean value theorem for integrals, Rolle's theorem, the sandwich theorem, sure. Sandwich or squeeze theorem. You guys have to do anything with that on the AP test this year? No? Those of you that took the... What? Not here, okay. They usually don't, but there was one last year, or the year before. I think 2 years ago there was one. Anyway, sandwich theorem or squeeze theorem says that if g of x is less than or equal to h of x, but greater than or equal to f of x, so if it's squeezed or sandwiched between those two functions, and the limit as x approaches a of f of x is equal to, we'll say L, which is also equal to the limit as x approaches a of h of x. If this is true, then the limit as x approaches a of g of x is also that same L value. So if g is sandwiched between f and h have the same limit at a, then g has that same limit as a as well. As long as these are all continuous. Right? Continuous at least surrounding a. Good or no? People in Zoom that are listening, good with that one or no?
Yeah.
Great. The only other one I could think about really is the fundamental theorem of calculus, which I'm guessing is not what you were sort of looking for, but we'll talk about it anyway. Fundamental theorem just says that the derivative of the integral from some constant, we'll just write c x c dt is equal to f of x dx. Right, so the derivative of the integral from a constant to x of some function is just that original function in terms of x. The derivative from a constant to f, well, we'll call it some other function g of x up here. So this could be x squared, or it could be 7x, or it could be sine of x, some other function of f of t dt is f of g of x times g prime of x. I'm not sure why I wrote a dx over that earlier. There shouldn't be a dx. Everybody go with that? So you take f and evaluate it at g, and then multiply by the derivative of g. That's the first part of the fundamental theorem of calculus. Everybody go with that? Other theorems we can think of? Yeah. So the limit definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. It is also sometimes written as the limit as x approaches a of f of x minus f of a over x minus a. So these are both the limit definition of the derivative. And oftentimes in the multiple choice, those of you that took the test yesterday, maybe you can tell me if you saw one that was similar to this, like the limit as h approaches 0 of something.
Yeah, I saw one.
There was one. Yeah, there usually is. Yeah, some. What? It was f of 5 plus h, like that? But they didn't tell you what f of f was? Tangent? Tangent, you think?
Oh, it was tangent, yeah.
It was tangent. So something like this. So this apparently was on the test yesterday as well.
They had f, but they told us f of x is tangent x, I think.
Oh, so this is totally different problem then. Here we go. Okay, so this is we're not breaking any rules here. This is a different problem for sure. This is the limit as h approaches 0 of tangent of pi plus h minus tangent of pi over h. So what this is this is the limit definition of the derivative of tangent. So this is the derivative of tangent x at x equals pi. And so the derivative of tangent is secant squared. So secant squared of pi. And we should know that the secant of pi is, those of you that took the test yesterday should really know what the secant of pi is. Secant of pi is -1. So this is -1 squared, which should be 1. Yeah. So then the other way you could do this is you could look at it as if you plug in 0 to this, you get 0 over 0. So you could use L'Hopital's rule on it. And then you'd have the limit as h approaches 0 of secant squared pi plus h. And then minus, well, the derivative of tangent pi. Tangent pi is just a number, right? The derivative of tangent pi is just 0, and the derivative of h is 1. So you end up with, again, secant squared pi, which is just 1. Good or no? If you were to see that question on the AAT test or one similar to that, you would recognize right away how easy it was and you would complete it. No problem at all. Is that correct, everybody? Good. Yeah, the hardest part is, knowing the prerequisite information that you were supposed to have before you started this class. Yeah. Yeah. This is the part where I get frustrated, where I'm like, I can teach you how to do calculus. You know how to do the calculus. The calculus is easy. The problem is that you didn't learn anything the last 4 years, and so you can't do basic algebra, arithmetic, and trig. It's a real problem. It's a real problem. Other things that you guys might want to talk about in particular. Otherwise, I'll start throwing some free response questions up for the people that are still taking the test on June 9th. Tori, you looked at me like, I don't care about any of this anymore. Why are you talking to me? I won't talk to you again. Don't worry. For next year, when you take Calc 2. The 150, 151. Yeah. Volume of what? Here, let's do this. Let's make up a problem. Let's say that we have a cube that is shrinking. A cube that is shrinking. And the area of the base went from something like this, maybe from like 4 to 3.98, something like that. Is that?
This one was a related rate problem, but you had to like do 2 different related rates, I think. I don't know.
Let's do this. Let's say I'm sorry, hold on 1 second. Sorry, I had to get really annoyed with somebody because they said, I guess C for ice cube. And so I had to spend some time yelling about that, but I didn't want to say anything that could be heard in the Zoom because of the recording. Very bad. Okay, please what? That's literally me, not he, calc. Does that even mean something? Did he made a typo? Oh, that's you on the, I hope that calc means calculator, not calculus. All right, let's say we've got a cube that's shrinking with the, let's say, should we have the cube be shrinking at a certain rate? Does that sound familiar to people? All right, shrinking at 0.03. Let's just go with 0.02. Why not? 0.02. The side is shrinking at 0.02 something, or the side or the area? Okay, here's what we're going to do. I'm done listening to all of you. We're going to have the cube shrinking at 0.02 feet cubed per second. And we want to know, let's say we want to know what the area of one side is changing. When, let's say when the side length is 3. Whatever, face, side, same crap. Okay. We'll call it one face. When the side length is, when the length of the side is 3. So we would say that the volume, which is the side length cubed, ought to be dv dt is 3s squared ds dt. And so that should tell us how the side length itself is changing. And so dv dt was 0.02, should be 3 times the side length squared ds dt. So that should be 0.02 over 27 for dv dt. And then, sorry, for ds dt, not dv dt, ds dt. And then if we want to find out how the area of that face is changing, well, the area is the side squared, right? So dA dt, the change in the area, is 2s times ds dt. And then our s, like we just said, was 3. So this is, cancel the 3's out there, you end up with 0.04 over 9. That's how you'd go about something like that. Happen to show up. A multi-step related rate. Choice C for ice cube. Choice F for failure. Any questions there on that one? Does that make sense? Other questions people might want to talk about? Anything else? Otherwise, we'll do some free response. This has absolutely nothing to do with optimization. That is correct. Where are you going? Is that why your shirt says I know where I'm going? Huh. All right, free response question time it is. What do you guys want to talk about? Anybody have a particular type of free response you want to do? Graph FRQ, sure, those are fun ones. Those are good. There was one of those on the AP test yesterday. They should, I assume they're going to release the ones from the 24th administration also soon. So yeah, it's okay. So they still will be. I assume that they would be. I believe we've done that one. I think we did this one too. Did we do this one? We did this one? All right, this one's up next then. So I will give you guys 15 minutes to work through this one. Part A. We're going to find all values of x on the open interval where f has a local min. This is the graph of f prime, so f has a local min. If f prime goes from negative, I don't know why I drew a line that way, from negative to positive. So it looks like that occurs at this value. What is that? 1, 2, 3, 4. Because f prime has to, oh, that's positive and negative. Yeah, you're right. Sorry. I know my difference between positive and negative. Thank you, Emily. I guess. We went from negative to positive here at 6, and so that's where we have it. I wrote negative to positive, but then I picked the one that went positive to negative. Everybody good with that? Yeah, all of you people in here, good. Zoom, good? Good. All right, part B, determine the absolute minimum of f on the interval 0 to 8. Well, it could occur at 6, or it could occur at one of the endpoints, 0 or 8. We know that f of 8 equals 4. So f of 6, I'll do this over here, f of 6, which is what we need to figure out, ought to be 4 plus the integral from 8 to 6 of f prime. And the integral from 8 to 6, well, that should be 4 minus the integral from 6 to 8 of f prime if we flip it. So that ought to be 4 minus 7. And then it could also be potentially at 0, so f of 0. And I'm just going to do this time, I'm going to write 4 minus the integral from 0 to 8, because we're going to have to flip it anyway. So it'll be 4 minus the integral from 0 to 8 is 2, plus 6 is 8, minus 3 is 5, plus 7 is 12. So we end up with negative 8. So our absolute min should be at 0. And that was worth 3 points. The first one was worth 1 point, and that was worth 3 points. 1 for checking x equals 0 and x equals 6, 1 for the right answer, and 1 for showing the other values were more than. Does that make sense to everybody? Zoom, you good with part B?
Good.
Hey, part C, part C, when is f concave down and increasing? So concave down if f double prime is negative, and increasing if f prime is positive. So f prime is positive everywhere but here. And then f double prime is negative if the slope of f prime is negative. So that'd be 0 to 1. Then the slopes are positive. Then the slopes are negative from 3 to 4. So 0 to 1, 3 to 4, and then they're positive again. So it looks like 0 to 1 and 3 to 4. Everyone good with part C? That was worth 2 points. Goodbye, whoever left. Part D. So G is f of x cubed, f of 3 is negative 5 halves. Find the slope of the line tangent to G at x equals 3. So we want, so I'm going to write this out here. G of x is f of x cubed. And what did it say? F of 3 was negative 5 halves. And we're writing the tangent line, or just find the slope of the tangent line? Find the slope of the tangent line of G. Okay, so G prime ought to be 3 times f of x squared times the derivative of f of x, so f prime. Write that as an x. And then we're going to evaluate that all at 3. So 3 times negative 5 halves squared. And then f prime of 3, we'll look at the graph. What was f prime of 3? Looks like that was 4. So whatever that comes out to be, what is that? Negative 75. That was worth 3 points. Oh, sorry, positive 75. Not negative. I just looked at the negative and said negative. So 2 points for the correct derivative, 1 point for the correct answer. Good? Yeah, don't forget the chain rule. And then you got it wrong. Yeah, don't forget the chain rule. Chain rule, you get that f prime. Cool. All right, let's do another one of these. Let's do this one. This one looks fun. You have till the end of class to finish and work on this one. Ready, go.